So, okay, let me rephrase again. So here we're talking about concavity. So I want to spell it correctly. So concavity. Concavity. Yeah, concavity. If double prime of x greater than 0 is concave up, use your hand gesture. This is concave up, and this concave down. Or I like this one better. And I can say if a tangent line is below x-axis, then that's gonna be concave up. If tangent line is above the graph, it's concave down. Now, why is that useful? Remember this. Now it probably doesn't make sense. Later on, we're gonna use the tangent line to approximate the function. Now, if it's concave up, your tangent line is always under approximation. If here, the tangent line is always over approximation. We can come back to talk about those. Now, right now, it probably doesn't make sense, but later it's gonna start making more sense. Definition of inflection point. It's a point where you have a concavity change. You have a concavity change. So a point where you change your concavity. For example, you have something like this, right? You have some function like, could be like this, right? And this point here is the concavity change because it's changing from down to up. So you're gonna have those points out there. It's called inflection point. So a point where you have a concavity change is where a concavity change. That's it. Now, if you want to justify something, like AP exam, right? Now, like I say, I'm not a big fan of AP exam, but we had to beat that test. That's the only thing I care. I don't really care if you hate it or I hate it just as much as you do. But in the couch calculus, it's not going to look like this. It doesn't ask you to justify something. But in AP calculus, it does ask you to justify something. But how do you justify for inflection point? Now, this is how you justify. It's f double prime of x change. So f double prime of x change from negative to positive or positive to negative. Or you can say change in sign. If they change the sign, then there's an inflection point. You have an inflection point at this x. So if you have double prime of x change at 2 from positive to negative, guess what? That's an inflection point. But you had to write it this way. F double prime of x changing from positive to negative. Now, the second thing you had to pay attention to is the possible inflection points. The possible inflection point is just like critical numbers. Is f double prime of x is equal to 0 or f double prime of x equal to undefined. Now, they are only possible. Why I say possible? It's a candidate. It's not for sure. You're running president doesn't mean you're going to become president. Okay? So it's just a candidate. So you have to prove it by the number line. You have to prove that there was a positive and negative sign change. You see the sign change? There's an inflection point. If you did not see the sign change, there was no inflection point. You can possibly get positive, positive, negative. Then between positive and positive, there's no inflection point. Between positive and negative, yes, there's an inflection point. So that's a thing that you should pay attention to. Now, some people says, what is the tangent line look like? And I built a function look like this. Oh, sorry.
So f double prime equals 0 and f double prime equals undefined?
It's the possible inflection point. It doesn't mean that double prime of x equal to 0. It's an inflection point. It's a possible inflection point. You have to test with the number line because you can possibly get positive, positive. There's no inflection point. Sorry.
So you said if it's double negative, then there's no inflection point?
No, if you don't have a sign change, then there's no inflection point. Whatever sign change occur, that's your inflection point, like your maximum and minimum. Your maximum is changing from positive to negative. Your minimum is changing from negative to positive. Now I built a function for you to look like this, and it help you look at the concavity. This is a perfect way to think about it. Do you see this?
Oh, I love that.
Now I totally keep rocking along in the water.
Now, if you pay attention, right? I'm gonna pause here. Oops.
Oh, that's great.
So now, if you see this, at this moment right here, at this 2.69 there, it's concave down because that line is above the graph. And the line is always above, it's concave down. And then if you play it more, and then you're gonna see at different point, so this is concave down, right? Concave up, do you see that? But past the origin, see, this is the point where it's changing from concave up to concave down. Do you see those?
Yeah.
That's beautiful.
I don't know.
Explain the formula.
Oh, can I explain up to? Okay, so Ethan say, can I explain? That is a formula you learned in Algebra 1. It's y minus y1 equal to m times x minus x1. Why is m? M is f prime. F prime at a value. A could be changing. A is constantly moving around. Now, x minus a is the x value. How do I get y value? F of a. So if I assign f of x equal to tangent, so it turns out I don't have to use tangent of x. I can say sine of x.
So what disappeared?
Oh, I love
that roller coaster. Yeah.
Oh, so it's changing its concavity when it like goes down. Like it could change like right there.
It changed at 0, see? Yep. It changed here. Yep.
And when's concavity? Like when it's like this?
Yeah, so you can tell by the look in the tangent line here.
Where?
You can change the function. Now, what do you want to change? You want to change to C S C of x.
I'll just do X.
Yeah, kind of like a ninja warrior. Yes. It's pretty interesting. Yeah, but so I built a tangent line just for this. It's actually pretty cool. I think you guys can play with it too. You can build this equation. It's just equation tangent line. That's the biggest part on the AP exam. They will ask you build equation tangent line. You just have to build it. Linearization is the equation tangent line. Okay, so those are things that you should pay attention to. Now, is the work anything different? No. It's going to be just do the second derivative. Find the second derivative equal to 0. Second derivative is undefined. And you're going to find out that the first derivative is right here. I did a chain rule. And then I did a number line test of increasing, decreasing. Now, that's the first derivative. I'm going to do a second derivative. I had the quotient rule. I can act around it because it's not 12x. It's not 12. It's 12x. So therefore, I did quotient rule. I did it all done. I get up to this point. And I say, I'm going to test -1 and 1 because the bottom can never equal to 0. I don't need to test that part. I just test between -1, so it's going to be concave up, concave down, concave up. Now, guess what? Inflection point is right here. So it's IP. And this one is also IP because IP stands for inflection point. So you can change that. So you see the sign change, inflection point. It does not have to be like positive to negative. It could be a sign change. If you sign change, automatic inflection point. Yes.
Say it doesn't matter about the denominator. Like you're saying, like can equal 0.
Yeah, because the bottom, right, can never equal to 0. So it'll be x squared plus 3 is equal to 0. X squared equal to -3. X equals square root of -3. That's going to give you I. There is no critical numbers. By the way, your first homework question, you might need a double angle formula.